Hello, and welcome back to part two of Computer Science Unplugged. My name is Rebecca Gibney, and I am the coordinator of professional learning here at Blast Intermediate Unit 17. Today's presentation is a continuation of obviously part one, Computer Science Unplugged. If you did not have a chance to view that, I strongly suggest viewing that portion first and then continuing to this portion. You can find that segment in the online learning hub under Computer Science Unplugged Part 1. After today's presentation, if you have any questions about either part one or part two, please feel free to reach out and email me, or you can direct message me on Twitter if you are someone on Twitter. So today's presentation is actually a product of a collaboration between 5 different IUs: Bucks County Intermediate Unit, NEIU 19, CSIU, and LIU. It's also a product of what we call PD Pals, which is where all of us IU people, STEM point of contacts, get together and create professional development that we can bring to you. So again, today our objectives, same thing as in part one, is just to understand computer science, practice a computer science mindset, and then develop strategies for how you can practice computer science with your students and even advocate for computer science with your colleagues. Today's process, we're going to talk a little bit more about fostering future ready skills and also like empowering students to take action. And then we're going to even dive into how do you advocate when there's so many barriers in the way, right? Or that some people, some of your colleagues might think there are barriers in the way. So let's get started. We're going to foster future ready skills. I want you to think about, this ties really nicely with Pennsylvania career readiness, right? College and career readiness. But if we focus on the career piece, I want you to think about how technology and computers have changed jobs in the past year, in the past 3 years, 5 years, 10 years. How are these computers and the different technologies out there, how are they getting ready to become contributing factors in the workforce? How is that helping it? Do you recognize the changes that computers and technology have made in this workforce? So think about, maybe we'll pick the past 10 years and you can hit pause on this video, make a list of maybe 3 to 5, I have here 6 jobs that didn't exist 10 years ago, and then make a list of 3 to 6 jobs that no longer exist or have changed. So go ahead and pause this video if you'd like to, or you can keep going along with me. And please remember that all of these activities you can do with your students as well, or with colleagues too. So if we look at jobs that didn't even exist 10 years ago, what about a switchboard operator, a pilot, a taxi driver, typist, bomb squad? How much has that job shifted because of computers and technology? Travel agents, soldiers and guards, cashiers. Sometimes we don't even have cashiers because we do self-checkout, or I just order my food on the app and it gets delivered to my house. Or warehouse workers. All of those jobs have changed or been eliminated in the past 10 years. And now let's think about the left column here, jobs that didn't even exist 10 years ago. Market research data miner, big data analysis, cloud services specialist, app developer, SEO specialist, social media manager, digital marketing specialist. All of those jobs have been created in the last 10 years. They basically say right now that we are educating our, let's say, kindergarten students for jobs that don't even exist yet. And that is mind-boggling to me to think about. That's why it's so important to teach these skills that come along with teaching kids computer science and even STEM. So as we continue, all of these jobs, talking about those skills, we're fostering future ready skills in the process. These unplugged activities really, really aim to focus on emphasizing and reinforcing the future ready skills. Things like critical thinking and problem solving, if they have to debug a situation, collaboration across networks and leading by influence, agility and adaptability. How do you adapt to the situation? Initiative and entrepreneurialism, my favorite. I love seeing the kids, and we're going to talk about this in our next skill. I love seeing them take initiative, take action, advocate, come up with new ideas. Part of one of my fun parts of the many fun parts of my job is doing the student competitions and seeing them create and seeing them, like they said in bullet one here, critical thinking and problem solving, but even just that entrepreneurial side, they could take that creation and then turn it into entrepreneurship. How do they effectively communicate orally and written? How do they access and analyze information? Part of that engineering design process. You have to think about it, you have to research it, ask the question, all of those things. The curiosity and imagination. Many of you watching this probably have gone through my Start Soul training thinking about like this big question and then I'm curious about this question. How do I research and find answers? Okay. So if I were you, what I would do is I would also take some time right now to pause this video, look back at some careers that have changed due to computing and technology. And I'd ask you, identify some of those general tasks that that person might do. What did they do then? How did they do it without computers? And then think about now, how did they do it with the use of computers? Oftentimes, it's efficiency, right? The job gets done quicker. Having that discussion, you can have this with this activity with your students, having that discussion about the future ready skills, and then look at this list. What does that, what changed? Maybe because it's done by a computer, your communication, oral communication is not as strong. Whereas accessing and analyzing the information might be stronger, right? So that's something to think about. And at this point, we're going to stop. We're going to think. We talked about in part one that UDL process. So if you do this activity with your students, right? If you do this activity with your students or your colleagues, thinking about the importance of the why behind computer science, okay? We talked about those 5 big reasons why computer science. We talked about the UDL framework, okay? How do we get all kids involved? Engagement, representation, all of those things. So take a second, and if you need to refresh your memory, go back to part one, refresh your memory on the UDL, Universal Design for Learning. Stop, think, how can I make this activity accessible for all of my students? And then we're going to move to one of the next top 5 reasons why students need computer science in their lives. And that's empowering students to take action. So I have this book here, and it's a great book. I would highly recommend it, but it's called Gabby's If Then Garden. And so if you teach elementary, even if you teach secondary, I often find that students love to just sort of listen and go back to, I always used to say, every kid is a kid at heart, even us adults, we're kids at heart. Read this book to them to introduce them to these if-then scenarios. It helps them learn how to take action. If this problem occurs, then here's the solution, right? And it also starts talking about some coding language, some coding vocabulary. So I'm not going to read this all to you, but I'm going to read a couple of pages here. So this is Addie. Addie likes art and crafts. She spends most of her time coloring, playing music, and making things. Whenever she sees something new, she wonders how it came to be. She likes to say, I wonder. And this is Gabby. Gabby loves to read, play outside, take care of her dog, Charlie. She is always curious about how things work. Whenever she sees something that needs fixing, she tries to find the best way to improve it. She often says, what if? Addie and Gabby make a great team. And so again, now we're going to enter into these if-then statements, right? Every spring, hopefully you can see this here, every spring, the girls help their parents plant their gardens. They prepare the soil, choose which plants they'll grow, and plant the seeds. So if you see, if it's sunny, then I'm going to water the plants, right? If the weather is dry, the sun, then they water the plants. If it rains, then they don't water the plants. If weeds start to grow, then they pull from the garden. If a rabbit eats their plants, then they must start over. And so, again, it's something that students can relate to, just even this page. And if you're an ELA teacher, right, or even if you re-emphasize the analysis skills, not only do you have if-then statements, but you can also look at this and say do some analysis, right? You can tie in both skills here. Today, Addie and Gabby are playing in Gabby's backyard. My mom said we could pick tomatoes. Gabby says, red tomatoes are ripe, green ones aren't ripe yet. If the tomato is red, then put it in the basket. If the tomato is green, then leave it on the vine. Then this book goes into saying and explaining if-then statements. If-then examples are all around us, at home, at school, and in nature. Computers use if-then statements in their codes. A code is like a set of instructions for the computer to make it perform a task, such as showing a video or playing a game. In coding, if-then statements are called conditional statements. The if is the condition. Different conditions or ifs will cause different outcomes or thens. If something happens, then the computer does something. For example, if you press the number 3 key on the keyboard, then a 3 will show up on the screen. If-thens are one of the ways we tell computers what to do. And I'm not going to continue going on, but this is a great example and a great introductory to read to your students to get them used to if-then statements, to get them used to conditionals, and tie it to real world actions. So, and that if-then garden you can purchase online. They also have a bunch of other books in the series as well. So when we start talking about this, and eventually it goes into else, if then else. We're bringing inquiry to action. And that's really important for our students. And that's really important for them to also relate to the real world. You do this every day, right? Prime example with gardening. Same with getting dressed in the morning. If it's cold out, then I wear a sweater, right? What will happen on this activity, and if you access the slides here, is we have a template that you can create your own. So you click on create your own, and you'll have a template that you'll be able to access and have your students access, and they can each make their own storybooks using if, then, and if you want to, else stories. So they can have their own theme, something they're passionate in. Maybe they don't get the gardening thing, but they can have something else that they wonder and are curious about, and make an if then storybook. So again, keeping in mind, how do I make this accessible for all students, this activity, this little thing that we're doing here? Okay. Once you do that, and we talk about these if then statements, we think about what curricular connections, maybe you could do this with another content area. What physical space might I need? All of those things. Do I want to do it digital? Do I want to do hand, like paper copies? Okay. Have them share with the world, have them share with each other, have them share with their parents or caregivers, anything to get them to understand it and relate to themselves. Those are 5 skills between part 1 and part 2 that are really important, and reasons why computer science is important for our students. But we all know that not every teacher is on board for that. You are probably watching this because you are a computer science champion. You are an advocate. But how do you keep advocating? How do you keep being a champion when not everyone buys in? And it's the same thing with our students. How can we get kids ready to use technology that can help them solve important programs? Oftentimes, for more ways than one, people get scared for the idea of programming, coding. They think that's only computer science. And if you remember back to the part 1 video, that's not everything in computer science. But if you start thinking, how can we get kids ready to use technology to solve important problems? Again, if you want to pause this video, you can pause it and watch this video. I'd say stop at 3 minutes, 47 seconds to be exact, but stop there. And it'll talk about, and it will help you brainstorm some answers to how we can get kids ready to use technology to help solve the problems when they're a little hesitant to maybe go straight to programming or coding. Right now, these 5 examples of activities that you can do with your students that I gave you in part 1 and part 2 here are excellent ways to start getting them to help learn how to solve problems without even starting to program and without even starting to code. Eventually, you can get to text-based programming, okay? But they don't have to start there. And you, as the teacher, don't have to start there if you're not ready. Start with some of these 5 activities that we just shared with you. But then we move to, like I said earlier, where does computer science fit in your school? Not everyone is ready for it. Not everyone is it a priority. So think right now to what's the reality of computer science at your school, especially right now in the pandemic? It's not a priority, right? For many schools, it's not. For you, it might be, absolutely. But why does it have to be pushed to the side, right? Could we integrate? Could we work together? Could we innovate to reimagine what this could look like? What are some common roadblocks that you hear for why not teaching coding? Take some time, and if you're talking with teachers, chart this out. Think about a column for barriers. Think about a column for priorities, and then think about a column for level of influence. After you make your list of barriers, indicate how each of these rate as a priority. Is it high? Is it medium? Or is it low? Is that barrier low on that totem pole? And then think about what's that level of influence? What's their impact change? Is it high? Is it medium? Is it low? We don't want to be moving in opposite directions. There's not a reason why computer science has to be on hold right now. Sure, it may not be the number one thing that's driving every single decision, but for you as a computer science champion and advocate, for you, you can be working to find ways to make it integrate, to help find solutions, to help grow that if-then garden. Okay? Because when we start talking about these new things, technology, right? Let's talk specifically for that, even computer science. There's this, right? Diffusion of innovation. It's scary. And it is. We know that even right now in the pandemic, it's scary. And we talk about how people jump on board. Now, this model is from a marketing model, right? And what we can do to market things to them. But I want us to take a look at this diffusion of innovation. And when you think about the colleagues you work with, and even the students and sometimes caregivers, right? It's a mindset shift of even the community. Look at this here. And as I talk about like the diffusion of innovation here, the champion status, I want to look at it a couple of different ways. One, you can look at it the first time through as your colleagues that you work with. Two, you can look at it as look at where you fall on computer science here and this innovation. What is your champion status? And then you can also look at it from the student perspective. Where do students fall? Your students fall on this diffusion of innovation. If they're at innovators, that 2.5%, if they're at innovators, this is just a small group of people, but they're those ones that they're like, yes, this is awesome. I can eat, sleep, and breathe computer science. Give me more, right? But then you move to early adopters, which is a little bit more, 13.5%. These are the ones that takes little persuasion to be receptive to change. They just sort of need to hear it once, hear, that it's a cool new thing. There's some positivity, there's some positive stories about them and testimonials, and they're on board, right? Little persuasion. You got 13.5% of the people you work with there. Then you got the early majority. These are the ones, 34% of them, so it's tied for one of that top high percentages there. Majority, early majority here, they read the reviews, could be from the early adopters and the innovators, more than likely the early adopters, but they read the reviews and then they decide if they're going to purchase or if they're going to dive in. Okay. Whereas the late majority, another 34%, they're not really keen on the change. They'll adopt the new product only because, though, that they have this fear of missing out. If I don't try this, I'm going to be behind. And that's okay to get them on board that way, right? You got to make it so enticing that they're afraid they're going to be missing out. But then you have that 16% that are the laggards, right? They want traditional paper, pencil, let's lecture, right? They'll adopt new products, but only when there's no other alternatives. They prefer that they have research evidence, they have statistics, and more than likely they're feeling pressure from others. Maybe these are some teachers or some students that are like, no, you have to be in this class or you have to do this, right? It's important to understand where people fall in this diffusion of innovation. For you, it's important to know where you fall as you're advocating and championing computer science. It's important for you to know where your students fall and take some time to think about how can I support them so that they're not laggards, or if they are laggards, how can I reach them? And the same thing with your colleagues. If you're trying to grow computer science in your school, think about where all of your colleagues fall in this, and then think about how could I persuade them, to jump on board, knowing their personalities and what they're like. Okay, really important. So what I want you to do now, I asked you to take it off of 3 lenses. I'd like you to take it off of the lens of where do you fall? We're going to do a little bit of work here. Just where do you fall? You need a minute to pause the video, take it in. I want you to write a promise statement to yourself. This is an independent activity, so if you're watching this with some other colleagues, please, do this silently. But I want you to commit to writing down a statement or 2 statements where you can either list or write it out in a paragraph if you'd like, but list an actionable declarative that's going to help you move up the continuum of this model. So that eventually, if you're at the late majority, you're going to become an early majority person, right? You can ask yourself, what might an early adopter look like? What might they say? What do I need to do to get to that early adopter phase? Because it's very possible to move up the continuum. Because in order to move up the continuum yourself, and even as a building, you have to help others and improve the school in this model. So take some time to do that. And then lastly, this fear of fear. I know it sounds super silly, but the fear of fear. We're living in it without even computer science, right? Just in the pandemic. When we're engaging in new paradigms or no education shifts, learning for educators can be scary. We can't even really even tell you what we're scared of because we're scared of our fear. The fear of fear often prevents us from thinking beyond that status quo, beyond outside of the box. And sometimes maybe those laggards just have a fear of fear, right? And they just can't get past that. But, write some vent it out right now, right? Write some things down. What are some frustrations that you're dealing with? What are some fears you're holding on to? Alleviate that by writing them down. and look back at when you were successful. More than likely, when you started, you had a little bit of fear. And so your tasks almost seemed like a pointless endeavor, right? But when you did succeed, you look back at it and your fear now sort of seems a little silly. I used to have a fear of presenting for adults, right? When I first started instructional coaching, I was like, I don't know if I'm like an expert in any of this. Not that I have to be an expert, but I had a fear of that. And now when I look back on that, it just takes practice, right? All we have to do is try and be fearless. And that takes time. So I hope you enjoyed part 2 of Computer Science Unplugged. I'm going to urge you and challenge you, be fearless, try things, get people on board. Don't let a barrier hold you or your colleagues back. And try some of these strategies, these 5 activities that I gave you with your colleagues, with your students, because we do know that computer science, there is a need. There is a need, and the time's now.